This question asks us to use transformations to construct the graph of y equals 2 to the x plus 3 minus 5. So I'm going to start with f of x equals 2 to the x. This is the foundation of this. And we're going to go ahead and move things around, shifting them to the left and down. So we'll start with x. F of x is 2 to the x, 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8, 2 to the negative 1 means 1 over 2 to the first, which means 1/2. 2 to the negative 2 is 1 over 2 to the second, which of course is 1/4. And 2 to the negative 3 is 1 over 2 to the third, which is 1/8. So that's the graph of f of x. Let's plot those points on Desmos. So let's do that. And so we have our points that correspond to 2 to the x. 0, 1, 1, 2, 2, 4, 3, 8, negative 1, 1/2, negative 2, 1/4, and negative 3, 1/8. Whoops. So this is the graph of y equals 2 to the x. We see that. Now, what do I need to do? Where are my translations? Well, I have 2 to the x plus 3. That's going to take f of x and shift everything 3 places to the left. Minus 5 is going to shift everything 5 places down. So what I would like to do next is y equals f of x plus 3, which is the same as y equals 2 to the x plus 3. What's that going to correspond to? Shift 3 places left. So what I'm going to have here is, instead of 0, 1, if I shift everything 3 places to the left. So here I've got x, here I've got f of x plus 3. My point before was 0, 1. If I shifted 3 places to the left, 0 minus 3, negative 3, 1. Shift 3 places to the left, 1 minus 3. Negative 2, 2. Shifted 3 places to the left, 2 minus 3. Negative 1 more, 3 places to the left, 3 minus 3, 0. 8, 3 places to the left, negative 1 minus 3, negative 4, 1/2, 3 places to the left, negative 5, 1/4, and 3 places to the left, negative 6, 1/8. So that should be the graph that I get when I have y equals f of x plus 3 or y equals 2 to the x plus 3. That's going to correspond to shifting 3 places to the left. Now, can I see that? So if I take all of these points, and I shift everything 3 places to the left. So again, minus 3 becomes minus 3, minus 3, minus 2, minus 3, minus 1, minus 3, 3 minus 3, 2 minus 3, 1 minus 3, 0 minus 3. So you can see how these green dots are these other dots that are all moved 3 places to the left. And that should be the graph of f of x plus 3 or y equals 2 to the x plus 3. Is that the case? It sure is. So we've done that. So these were our original points. I'll turn those off, and this was our original graph. We moved everything 3 places to the left, so now we have the graph of y equals 2 to the x plus 3. So let's take a look at that. So again, here's my original one. Black dots are here. Everything is moved 3 places to the left. You know, all I've done is I copied those points and I subtracted 3. So 0, 1 became 0 minus 3, comma 1. 1, 2 became 1 minus 3, comma 2, etc. And then I saw that y equals 2 to the x plus 3 is that graph. So great, I have all of those points. Now what do I need to finish? So I currently have y equals 2 to the x plus 3. If the last thing I need to do is y equals 2 to the x plus 3 minus 5, right, f of x plus 3 minus 5, that of course is shifting down 3. So we shifted left 3 here. Now we're going to shift down 5. So I had negative 3, 1. So negative 3, 1 minus 5, which is negative 4. Negative 2, 2 minus 5, which is negative 3. Negative 1. 4 minus 5 is negative 1. 0, 8. 8 minus 5 is 3. Negative 4. A half minus 5 is what? Negative 4 and a half. Negative 5 a quarter. What's a quarter? Take away 5. It's negative 4 3/4. And negative 6 a quarter, an eighth minus 5 would be negative 4 7/8, which is negative 4.875. So these should be the points. Again, first we took our original graph was 2 to the x, shifted everything 3 places to the left, and now shifting everything 5 places down. So let's go ahead and plot those points on Desmos. Again, there's our original 2 to the x. There's 2 to the x plus 3 shifted 3 places to the left. I'm going to turn all of these off. And I'm going to just go ahead and plug in the points that I just created. So let's go ahead and do that. So here's Desmos. I've turned all those graphs off. I'll turn them on again for a second just so we can remind ourselves of what we have. Here's our original points. There's the graph through them. There's everything shifted 3 places to the left. So these green dots I now need to shift 5 places down. So we had negative 3, negative 4 was our first point, which you can see that here, right? Negative 3, negative 4. Our next one is negative 2, negative 3. Our next one is negative 1, negative 1. Next one is 0, 3. Then negative 4, negative 4 and a half. Negative 5, negative 4.75. And negative 6, negative 4.875. So we can see what we have going on here. We have an asymptote happening at this horizontal line at y equals negative 5, and then the thing is growing. So you might want to think about the domain and range on this. Domain will indeed be all real numbers, but range will only go down as far as almost negative 5, not quite get there. So let's go ahead and look at our original dots. Those are our original dots. And then we move them 3 places to the left. And then we move them 5 places down. We should change the color on those so we can see that. Original moved 3 places to the left, moved 5 places down. And that should be the graph of y equals 2 to the x plus 3 minus 5. And sure enough, you'll see that it goes through all of those red dots. And here, if I turn on the original graphs, you can see blue function is 2 to the x. Purple function is 2 to the x plus 3, shifted 3 places to the left. Red function is 2 to the x plus 3 minus 5.